So factorising, what is factorising? It's kind of the opposite of what we did in the last video, which is to expand brackets. So we're trying to go backwards the other way and put things into a simplified state, possibly inside brackets rather than expanding brackets. So just a little bit of blurb here. In each term in an algebraic expression to be factorized contains a common factor. This is an important here, common factor. What is a common factor? A common factor is a number or term or expression or whatever it might be that happens to be contained in every term in the equation, in the expression. So for example, looking at these two here, 9x squared and 81x, what do they have in common? Well, they have x in common, not x squared, just x. They've both got an x. They both could be divided by 9 as well. So in this particular expression, 9x squared plus 81x, we can say the common factor is 9x. What do we do with the common factor? We then separate that out. We place that, say, outside of the brackets. We'll often use the word as taking out the common factor. Taking out the common factor is find out what it is first and then just write it down. So 9x is our common factor. Then we will create a bracket and the rest that we haven't taken out of these terms will fall inside the bracket. How do we know what that is? We simply divide everything in the original expression by that common factor. So 9x squared divided by 9x just leaves an x, and plus 81x divided by 9x gives you 9 basically. And you can test that you've got it right by multiplying and expanding again, and hopefully you'll end up with the original. So that's the basic idea of taking out the common factor and factorising. It gets a little bit trickier. So we'll look at this one here. Factorise 2a squared minus 8ax squared. Well, what have we got in common in both? There's an a there and there's an a squared there. So I'm going to say a is a common factor. I'm just going to write it down. Looks like x there. Oh, but there's no x's there. So no x's involved in the common factor. What about the numbers 2 and 8? Well, I can clearly see that 2 therefore would be a common factor because you can divide 2 by 2 and you can also divide 8 by 2 without remainder. So we'll say that 2a is our common factor. So we put that outside the brackets, create an empty bracket, and now let's decide what's to put inside the brackets. Divide 2a squared by 2a is just a. And then we've got minus 8ax squared divided by 2a, which will give us minus 4x squared by the looks of it. There we go, and that's factorized. There's no, once it's factorized, a good way of knowing whether you've done it completely is look at what's inside the brackets. Is there anything in common between these two terms? A, 4x squared, clearly not. There's no common factors left, so we've took them all out. Okay, so that's that kind of one, an algebraic one with letters. Here's another one. Factorize 7x squared y minus 35xy squared. Well, okay, let's look at it systematically here. Let's look at the numbers first. 7 and 35. I can see that 7 is a common factor because I can divide that by 7, and I can divide negative 35 by 7. Easy. What about x's? We've got an x squared and an x, so the highest common factor there is just an x. We can't say it's x squared because there's no x squared in this one. Let's go to the y's. We've got a y there and we've got a y squared, so y is the highest one we've got. So 7xy is our common factor. Create the bracket. Now let's divide each term by our common factor. 7x squared y divided by 7xy just leaves us with an x, and the minus 35xy squared, that will give us a minus 5 because it's negative 35 divided by 7. The x goes and y squared divided by, leaves one y there. So I've gone off the page here. Y. So that's factorized. Alright, so those are some basic ones to get you started. There's another method we can use called grouping of terms. Sometimes you might get 4 things here. And you think, okay, I've got x cubed, x squared. Oh no, but there's no x in 12. What am I going to do here? Maybe I could just do the numbers, but then, oh no, that's x cubed. That's just a 1x cubed. So there's no common factor. But what you can do here is group the terms and take the first two and the second two, not leaving behind any minus and plus signs here. Let's take the first two. Can we get common factors here? X cubed and 4x squared. Clearly the common factor here is x squared. They've both got x squared. Let's look at the second two terms. Minus 3x minus 12. Well, no letters, but the number, I can divide both of them by 3. So I'll say, well, minus 3 is a common factor there. So, okay, where does that take us? Let's just now take each, once again, go back as if it's in two parts, the first two bits and the second two bits, and do the factorising. So x squared, I'll just go down here a bit, x squared. What would be in the brackets here? Well, it'll be an x, and then plus 4, I think, yeah. And then the second set of numbers, these two, well, minus 3x divided by minus 3 will be, well, that's going to be 1, isn't it? And, sorry, not 1x. Really, I should have just called that x, shouldn't I? So I'll scrub that out. Minus 12 divided by minus 3 is 4. Alright, so I've got a minus 3 here. And excuse my scratchiness there. Got minus 3 outside the brackets and x plus 4 in. As if by magic, you can see that both brackets have got the same things in them, x plus 4. That means we can do something very clever and say, well, I've factorised this. It's now x squared minus 3, which are these two factors here and here. And I'm going to put them in a bracket. And the other bracket, the other factor, is x plus 4, because that's a common occurrence here. So I've managed to factorise that into two brackets. Really clever little sneaky thing you can do when you've got 4 terms. Doesn't always work, but always worth a try. In this case it did work. And if you get a question like this in a test or an exam, you'll know that there probably is a solution, and you can do it this way by grouping the terms, doing them 2 at a time and then bringing them together here. One last thing I wanted to talk to you about in this video is the difference of two squares. Hopefully you've seen this before in year 10. The difference of two squares is like a formula or a rule whereby if you've ever got a number here, a square number, remember a square number is things like, well, anything that's squared basically. But normally you've got perfect square numbers like 16 and 25. But sometimes square numbers can be x squared or y squared or z squared. So if ever you've got a square number, take away another square number, you can factorise that into two brackets as follows by saying, well, it's like having a plus b multiplied by a minus b. For example, well, let's just look at this one here. 3x squared minus 75. Well, the first thing I'm going to do here is see that there's a common factor of 3. So I'm going to take the 3 out. Sorry, go back. Get the pen working. I'm going to take the 3 out here because that's a common factor. And then what's left? X squared minus, well, 75 divided by 3 is 25. What you can see straight away here with this x squared minus 25 is that's a square number, that's a minus sign, and that's a square number, which obeys the rule of our difference of two squares. So that means I can change this to two brackets with a plus b and a minus b in the second one. Well, what's a? Well, if a squared here corresponds to x squared, then a is just simply x. So we're going to have x and x according to our little formula here. And b is our 25, because we've got the minus sign in the middle there. B squared, sorry, is 25. So that means b is the square root of 25, which is 5. So we're going to have 5 and 5. And of course, in the brackets in between them, plus and a minus, plus and minus. Don't forget the 3, that's all involved as well. So I've now factorised this into brackets. And why on earth would I do that? You'll find out later, because by factorising like this, it allows us to be able to solve these equations and find out more about what these equations look like on a graph, etc.